All right, let's this. Okay, so in this first demo, what we're gonna do is we're gonna just show step by step how to build a workflow in CyberWater. And in this workflow, we're gonna access some data agents. So we're going to get data products from the from USGS in this case, and from NCA LDAS. And using those data agents, we're going to make a small execution of the VIC model. And after, this is just for demonstration purposes. So after that, we're going to show a bigger demo where we have the VIC executing a much larger watershed just to showcase the capabilities of CyberWater. And also want to show different ways of visualize the data in CyberWater. So let's just start doing this. Okay, if you want to start a workflow as Rick showed before, you need to begin with, we need to begin with a space, defining a space and a time range. So we can just start defining a time range. So we have a module called time range where the user have to introduce the initial time and the ending time with the format described in the interface. So this example is 2010, January 1st, 0 hours, 0 minutes, 0 seconds. And we're gonna go all the way to the end of the year until 2011. And for the space range, we have a module called the space range, and we just drag and drop them in the main panel, and we can either connect them automatically as you guys saw, or the user can also control how they are connected. And here we are defining the edges of the area where we're gonna perform the simulation. So in this case, we are using, we're going to make, we're gonna collect data of the French Creek Basin. The French Creek watershed, it has a small area of 153 square kilometers and is located at the east part of Pennsylvania. So this area is the west, this is the west. No, this is the east. So east is minus 75.58. The west is minus 75.86. The Y maximum is the north in this case, 40.24, and this is the south. All right. So that's all we need to do to define where we want to make our simulation. And from this point, we just have to bring the data agents. And the one we're choosing right now is the USGS data agent. You just drag and drop it in the main panel. And by default, the USGS brings the information of stream flow in cubic feet per second. So we want to obtain the information in cubic meter per second. We can use this unit conversion factor to transform in from cubic feet per second into cubic meter per second. If you want to change the variable you're going to use, you can change the number here. So this number by default is the number you need for, or the USGS has for the stream flow. But if you want to know which other variables in which units do they have, you can click on the documentation button. And here you can see here in the variable code, you can see the information that we have provided of where in the USGS website you can go and see the list of all the variables and the units and the description of them. So you have all the information here. And this agent is capable of accessing all of them as long as you are consistent with the codes that they have. The USGS will bring the correct data. And after this, we only have to select our visualization module, which is called show chart. And this one, what it does is makes an average of the area that we have. But in this case, we have just a single station. So it's going to give us is the time series of that station. But if we had an area, then this would give us the average of the area as a time series. And what we need to change is to, because this USGS agent, it knows what the conversion is, but it doesn't know the new units. We need to specify the units here. Let's go ahead and execute this. So this is the information of the French Creek Basin using the USGS agent in CyberWater. Okay, so what I want to show now is this is the information average in a space, but shown in the as a time series. But we also want to show this NLDAS agent. I'll describe how this thing is done. So in this case, the space range is changed to the US, and we're downloading the entire area of the United States using the NLDAS agent to request the temperature. So the NLDAS or all the LDAS agents that are offered from NASA require the users to have a user account. So that's why CyberWater is requesting a username and a password. But what I want to show here is that just by requesting this, what CyberWater is doing is retrieving a map for every single one of the time steps that are available for that data agent. And one of the ways to visualize this space-time change is using the MSM animation module, and where the user can appreciate the changes in space and time of the data that we're downloading. Okay, so now we're gonna start to build the example of how to run Vic for the French Creek Basin. So just, we can start a new workflow, and we can copy and paste these time and space that we have built before. And we can have these boxes of the password and the username. Because we're going to use the NLDAS. The NLDAS requires the data of the password and the username. So this password, you can bring it with the password box dialog that is available through the Visuals interface, and the username is just a text dialog, and I'll show you how it works. So we'll bring the NLDAS agent. Oh no, this one is the NCLDAS agent, because we're performing a daily simulation, and the NCLDAS is the data set that is a data agent that retrieves daily information. So we make the password port visible and the username port visible. We connect this one to which port. So if you hover the mouse over the ports, the interface will tell you which port that is. So this one will be connected to the password, and this one will be connected to the username. And the one that says case study, the case study is the combination of the time range and the space range. We're just going to go ahead and connect that. And here it gives us the option of, it gives us the option to select which variable we want to download. So let's begin with temperature. I think, no, I think it's precipitation. Let me see. The first one I have is, let's see. So I think it's precipitation. So let's bring precipitation. And we select here the precipitation, total precipitation rate. And these are the four forcing variables that we're required to run Vic model. We just need to connect this to this case study to just tell each one of these NCLDAS agents which information we want to download. And we're gonna do the same thing for the password here. So we just provide the password to every one of these. Password. Okay. The only thing that is required before we just go ahead and use the Vic agent is to do the data pre-processing. The temperature modules that NCL does, the temperature maps that the NCL does retrieve are in Kelvin, and the Vic that we have in CyberWater requires the temperature in Celsius. If you're an advanced user, you can perform the simulation in Kelvin. You need to change the configuration file. But by default, we have left this as Kelvin, and also the precipitation is brought in millimeters per second. But because we're making a simulation that is daily, we need the millimeters per day. So we have to make the transformation of the units. And for that, we have a module called the MSM unit conversion, where you just use an equation to perform mathematical operation over the variables. And we're going to use, so the new units is going to be Celsius. The operation is going to be X, is going to be the data set we're going to transform. And we're going to reduce to 173.15. So that's to transform from Kelvin to Celsius. So we know the transformation we're doing. We can copy and paste the module to do that with the temperature. And the transformation of the precipitation is going to be millimeters per second to millimeters per day. And is X time X6 400. And I think that's it. Okay. And the units are millimeters per day. Okay. And precipitation. Okay. And we have everything ready to execute the VIC. So we can just bring our VIC agent. It's very easy to use. You just, as we have done in the entire workflow, just plug the data we need. We just need to make available the temperature maximum and the temperature minimum to perform the daily simulation. If you want to perform an hourly simulation or an energy balance mode simulation, you can activate all of them. In the description of which modules you have to activate for each case are all described in the documentation. So you can just go out there and check with things you need to connect. But here, so again, you can guide yourself with the names of the ports in order to connect them properly. So this is precipitation. This is going to be temperature minimum, maximum, and this is the wind speed. And after this, the two variables by default that Vic provides are the runoff and the base flow. And we can visualize them using the show chart module. So just connect them here. And let's just provide the units. Millimeters per day. We know is this millimeters per day. All right. So this is the password and the username, and these are the results of the simulation of Vic in the French Creek Basin. And to finalize the demonstration, we want to show a bigger execution of the workflow using a much bigger watershed. This is the West Branch Susquehanna watershed. It lies entirely inside Pennsylvania, and it has an area of 17,000 square kilometers. And we have previously prepared this workflow. We have it here. So what we are doing here, we just have to provide more data because we're going to run it hourly. So this is an hourly simulation of, I think it's an entire year. Yeah, this is an entire year from 1997 to 1998. And I here just trying to show different types of tools to visualize the data, and also to show how in the middle of an execution, the user can check kind of the state of affairs of the data that we are giving to Vic agent, for example. So here, we're not only using the Vic agent, we're coupling the Vic agent with the routing agent to compute the stream flow of the river. And we're comparing this stream flow information that we just simulated with the actual USGS measurements that we have using the USGS agent. So this is asking me my credentials. So these are two of the intermediate data that we have. For the routing, we need to provide a DEM map, and this is the DEM map. One of the options that the user has to visualize the data is an elevation map, and this is one example of it. This is the temperature map of this area of the West Branch Susquehanna Basin, and this is how it changes over time. This should be changing. I think it's just that the order these were plugged made this time just locked. And then this is the result. Yes, probably because of this. And this is the result of the comparison between the routing information that we just simulated with the US discharge that we measure. And with this, this is the end part of this demonstration. If there's any questions, please let us know.